Okay, we're good.
All right. Okay. So I'm going to go ahead and share my screen. So can everyone see my screen?
Yep.
Okay, good. Or can anyone, I guess. Okay, so yeah, thanks everyone for joining in. This is the first time that I think this type of Q&A has been done, and so I'm kind of happy to be part of something new, I guess you'd say, with Reactiflux. I've done a Reactiflux Q&A myself. My name is Nader Dabbit. I'm here with Richard Threlkeld. My specialty up until about 6 months ago was I was very big into the React and React Native community. I still am. I've since moved to work with AWS Mobile, and AWS Mobile is a division within AWS where we focus on building different services and SDKs that kind of help mobile developers build applications easier. One of the services that we work on is AWS AppSync, and that's what we're going to be talking about today. AWS AppSync is a GraphQL that is managed for you. A lot of people compare us to other managed services that are out there. So if you could think of a few that you've kind of seen pop up over the last couple of years, we're kind of in that same space. We're going to go into a pretty deep dive about why you, like what it does and why you may want to use it. And Richard was the original lead on this project. So he was one of the people that created this from the very beginning, and he has some very deep expertise about this. So whatever answers that that I can answer, he's here to kind of give the more technical answers. What we're going to do at first, we're going to kind of build a brand new GraphQL API, and this GraphQL API is going to be something that you may have originally built on your own. So if you're familiar with GraphQL, you've probably heard of things like Apollo and Apollo Client and Apollo Server. What GraphQL, what AWS AppSync actually is a replacement for your server. So instead of having to build and manage your server on your own, you can kind of use AWS AppSync, and all of the time and effort that we've spent kind of really polishing up things around authentication and multiple data sources and authorization. We kind of have that all built in for you, and you kind of only pay for the amount of time that your application is being used. So if you Google AWS AppSync, you'll see the documentation. There's some information around pricing there. But really what we're going to be kind of focusing on is getting up and running as quickly as possible with AppSync, with a GraphQL API, and also answering any questions that you may have. So Richard, do you want to do the demo, or would you like me to do a demo?
I'll jump into it, Nader. I've got a few things.
Okay, cool.
Yeah. So
one last thing for me, if you're interested in learning more after this screencast, there's an awesome AWS AppSync repo you can see here. You can just Google awesome AWS AppSync. This has a lot of links to documentation as well as tutorials and videos and things like that. And I'll go ahead and hand this off to Richard now.
Cool. Thanks, Nader. Let me try this really quick. Okay, I am sharing my screen. And Nader, just ping me if you can't see the screen fully. Let me know. It looks to be okay. So what I'm gonna do here really quick is just give like a slight little overview of essentially AppSync. So the way that I'm going to do this is just I want to like talk about all the features that we offer. So I'm really going to try to like fly through a short little presentation because I want to like spend the majority of this time like just going through the console and building some apps and showing you some use cases and stuff like that. Basically the the gist of this is
I think you dropped off, Richard. Hey, sorry about this. Just give us one moment for Richard to get back on. We're not sure exactly what happened, but I've just pinged him and he's getting back on.
hey, Natter, can you hear me now?
Hey, you're back.
I don't know why it kicked me off. Maybe it was that event mode. So I'll share my screen again. Cool. So let me jump back in. You can still hear me, Natter?
Yep, you're here. I can see your screen as well. Thanks.
Okay, cool. Maybe a network glitch. Okay, so anyways, we were trying to do all of these offline and real-time use cases and stuff like this, and people expecting data immediately, banking alerts and stuff like that. So what ended up coming around this was as we were going through the use cases and we were working through people, GraphQL was an emerging technology. And we wanted to meet these in a way that still allowed like a very open specification and allowed people to have flexibility with both, their resources and the ability for, them to also like swap in and out like different implementations in the back end. So what do I mean by that? Like, we could have just built a service for like offline and real-time data and like had like a very proprietary data protocol, as well as a proprietary database backend that you could only just use one thing, right? But we didn't really want like an opaque database or something new to add into this. And at the same time, like when we were building this too, like, many of you are probably familiar with some of the benefits of GraphQL. We wanted people to be able to start very low cost when they were either working on a weekend project or they were working on, the next version of, name your favorite social media website or something else, right? But as their business grew, then, or they started to like turn something in from a side project to like a real business, they could essentially, quote unquote, like, graduate out of that and change their backend to meet their needs, right? Because you've probably heard, best practices around only scale when you need to and stuff like this. So that was kind of like the ethos of what made us choose like GraphQL, as well as the ability to like kind of proxy to other data sources and resources in your own account. So like DynamoDB we support right now, Lambda, we support Elasticsearch. You're going to see some new things also in about a month here too of some different data sources that we're introducing. But additionally, like it wasn't just connecting to this. We found like a lot of people wanted to do all of these offline scenarios, right? Which I'll demo a little bit here for you in a few minutes. So this was not just offline, like, hey, I could like see some data, but like I want to maybe share data between multiple users. And when you do that, right, especially when you're offline and like manipulating data, you inevitably get into all of these different conflict resolution scenarios and stuff like this. And another big thing that we heard from people was, well, that's great, but I don't want to like push all the logic for handling conflict and merging data down to the clients. Because then if I like have a new app or an app that it's deployed to the App Store, anytime my logic changes, I need to redeploy that to the App Store and like change all of this stuff. So we built in like a bunch of features for doing like conflict resolution in the cloud for your own data sources and stuff like that as well. And then finally, like if you think about like what I'm saying here, right, we have the shared data, multiple users can operate and access different things. There was a big push that we got from people around security features. And on the screen, like we kind of talk about enterprise security features, but the truth is like people are building social media apps. Privacy is really big nowadays, all of these different concerns. You want to get like item level authorization on any of your different resources, whether you're using like AWS security controls or more open standards like OIDC and stuff like this. So these are basically like kind of the tenets that we started with when we were building the service. So what's GraphQL? I'm going to maybe fly through a little bit of this because maybe some of you are familiar with this, right? But GraphQL is right. It's an open data fetching spec. It's not actually an implementation, even though several of them exist. Like the JavaScript one is the most popular one, but there's there's GraphQL Java, there's Ruby implementations and so forth. It's not a graph database, right? You can use this with any backend, whether it's NoSQL, relational, HTTP, stuff like this. And this kind of differs from the traditional data fetching under the covers, because with REST-based architectures, if you were like trying to get blog posts and then like a list of comments on them, you'd hit multiple REST endpoints, you'd have to do multiple data fetches over the network. And the issue compounds itself when you want to start iterating through relational data, or you want to start adding authorization to all of these levels of controls. You end up with pretty poor tooling, pretty poor bandwidth operations. The data fetching requirements here in this sort of use case are encoded at the service rather than being specified by the front end developer. And GraphQL flips this on its head, right, by sending a request over the network just once, which you do according to the GraphQL spec in HTTP with either a post, which is the most common, or you can do a GET. And essentially what happens is your service parses this using a traditional tokenization and creating what's known as an abstract syntax tree, and forms a full tree to where the execution and the data fetching requirements are deferred until you hit a specific leaf, meaning the developers actually specified, I need this specific data from this field on this type. And what do I mean by this field on this type? Well, to do that sort of operation, you need to specify a schema at the service. And the way that we do this with GraphQL is we use something known as schema definition language, or SDL. And that is a strongly typed API, looks something like you're seeing on the screen here, on which you have one root level type, which is known as a schema. And that schema needs, at a minimum, a query type to be defined. So all GraphQL schemas need a query no matter what. They can optionally have a mutation, which modifies data, followed by an immediate fetch, or a subscription, which, according to the definition, is a long-lived connection that responds to changes in events. Traditionally, this is over a WebSocket. AppSync does this using WebSockets over MQTT, MQTT over WebSockets. And as part of this, with this SDL, you as the developer, which is a really nice model, can specify user-defined types like to-dos and give them friendly fields like IDs, which is a unique type in GraphQL, can either be a string or an integer, names, descriptions, priorities, and then you can return specific data that you want. So in this case, my get to-dos query that I've got has braces around it, which means it's going to return a list. And I say from my client get to-dos, I want just these 3 specific items back in what's known as my selection set. And the service responds just with that data. So that's essentially it from a high level. Now, with that in mind, how does AppSync work? Well, what AppSync does is you operate with the SDL. So we have a model of schema first, and you create and upload this schema. After that, you can connect it to data sources in multiple different ways. I'm going to demo a couple of different ways, like you can actually generate tables from schema and so forth, or you can manually wire them up. And at that point, it's a fully compliant GraphQL endpoint. You can do queries from it. You can do mutations. You can do subscriptions. If you're using our SDKs, this is all wired up for you automatically, and we have a plugin for the different Apollo SDKs across JavaScript, React Native, also native for iOS and Android. The data works offline as well. You can operate with the cache to do offline operations. Kind of sky's the limit from there. So before we went GA, and we just went GA about, yesterday was actually 2 months ago, we did a whole lot of features. So we had all sorts of stuff built in, like real-time with GraphQL subscriptions, automatic pagination, search capabilities, offline support, authorization. Months after, about a month and a half, 2 months after that, we released some features around auto generation of schema. Like you can have existing Amazon DynamoDB tables, and we'll inspect the key schema on that NoSQL table and build out some default things, including indices. We can also provision from the schema. We have a capability in the service to where you can use GraphQL subscriptions without actually writing to a data source. So you can turn a GraphQL endpoint into a pub sub engine and just basically fire off fake mutations and results to events. A bunch of features around API keys, and we're currently in something like, I want to say like 9 or 12 regions now. It's expanded even in the past few weeks. Also, we have expanded our GraphQL capabilities just from a raw spec perspective. So we support unions, we support interfaces built in to the GraphQL schema that you can create in AppSync. A whole bunch of utilities built into these resolvers when you do want to edit them, including time series generations and timestamps, date time formatting, utilities around automatically linking to S3 objects and buckets. I'm going to demo that in a couple of minutes. Passing through custom headers, doing fine-grained authorization, all of this. Then when we launched this service for GA, we built in a bunch of more features that really help developers day to day, especially when in the enterprise space. So we've got test and debug flows for resolvers when you're editing them, including in console. So we have capability of doing unit style testing to where you can run a resolver, and we use a templating language for scalability purposes and to lower the runtime, as well as not just a unit test, but a integration test style flow to where you can run queries manually and you can see what's actually happening in the execution plane, including the offset time from initial invocation and how long in milliseconds each test took to run. All of this integrates with a solution that we have called CloudWatch to where you can do metrics and alerting based on certain events, as well as full logging of the GraphQL invocation all the way down to the field level and see which fields were invoked and which weren't. You can automate all of this stuff, standing it up with CloudFormation, and you can also attach resolvers on subscriptions to do run at connection time resolution. So this is really important if you were building like the next big chat app that wanted private rooms or one-to-one rooms with people. You can actually lock down the capabilities so that people have to pass certain authorization checks before they're even allowed into a chat room. Also, we have released a separate GraphQL library that works with an extension of our Amplify library, which is an open source library for connecting to cloud resources. So we expanded the API category to not just handle REST, but also GraphQL. It's a more simplistic model, but it also comes with some capabilities around React, including render props with custom components and stuff like that. We added capabilities around doing batch operations, and it's also a fully, you can build HIPAA compliant applications on top of AppSync as well. You would need to do some things with the data sources that you use, but if you are building applications in that space, that this could be pretty valuable for you. So real world use cases, what are some people building with this? So the first is I talked about offline data rendering, especially if you're React developers, you're probably familiar with some of this code. But the way it would work is if you were using the Apollo client, you basically npm install the dependency of AWS AppSync client. You give it some config like the endpoint, the region you're using, and your auth type. So this is actually an example of where you would use our Amplify library for having a single line authorization and passing credentials through. At that point, we just pass this to the Apollo provider, and that is all you have to do to make data readable offline. If you want to write data offline, you can just do a mutation as normal, with the caveat that if you want your UI to show up immediately when you're offline, you also need to do a couple of other things like optimistic UI. But just to be able to persist data offline, that's really all you have to do as a React developer. Just pass it through. So Amplify, just kind of the note on that, since just to tie up that last screen, and you'll see I'm going to use it in a couple of the samples here in a second. This is a library for front-end development. You can pass through authentication and authorization information in here, storage, pub/sub information, all that you like. And this allows you to interact with some backends through GraphQL that aren't just data information, but you can also tie this up with images and rich content. So for example, we have a way that you can specify in your GraphQL schemas like a S3 object, like say it was an image or a video. And behind the scenes, if you do a mutation, we will pass the information to an S3 bucket. We'll load all of the data in a DynamoDB table, and we'll restrict it down by the individual user that's accessing it. So if you have use cases, right, to where people are going to build their own image sharing app or something like that, this is a perfect example of tying multiple services together with a single GraphQL endpoint and having a really rich experience. GraphQL subscriptions, I mentioned that we support this. We do this in response to events that happen on the system and transform that in real time going down to the clients. This works for any data source that you have. So if you're using Lambda, for example, you can actually call out to other things in your AWS account, like I don't know, maybe you have a Redis database or something else that you want to read and write from. And this will still respect the schema operations that happen. Finally, you can mix and match these with different data types. So you could start with a NoSQL database and then later add in search capabilities. And now you basically are creating this like Uber backend for search functionality. So you could have like, NoSQL as well as Elasticsearch as well as Lambda functions, and then reading and writing to S3 buckets, all from your single GraphQL API. Again, starting simple, and you can go from there. So I'm going to actually jump into a demo here, just because I don't want to go too long on presentations and stuff like that. So let me actually switch over to another region. You can see all the ones that we have listed here. And let me show you a little bit of a getting started demo. So you can start a couple of different ways. I'll do Thursday demo. One way that most people get started if they've never used GraphQL before is you can start with this sample schema. I'm going to demo that in a minute here of what that looks like. But basically, like, it shows like how you would create like an event app, which could also be like a CMS style system or a blog. But the idea behind events is like you could like add events to a system like, hey, meeting up this Friday night or something, and like people could add comments to these events. And this sample app shows us a few things. Like you can see I've actually got pagination built into this as well. Make this a little bit bigger. You can see I've got connections. I can do things like subscriptions. So the way that we do subscriptions is with this little GraphQL directive. And subscriptions are triggered in response to mutations that happen in the system. So here, whenever somebody comments on an event, I'll kick off a subscription notification. But because this is an array, I could organize this any way that I want. So it could be, one-to-one, one-to-many, or many-to-one, however you like it. But I'm actually going to do this building from a custom schema. So I click Create here. And you notice a couple of things. One, it brought me into my API, and it's already got from a warm pool a provisioned GraphQL endpoint here. We put this, expose this via global CDN. So we've got things like DDoS and everything else built in. The sample apps, so like you'll see, down here, here's the React starter app and React Native one, are all built into the console. You can just clone them, copy down this little config, and get going just if you were going to use that starter sample schema. And a little bit of navigation of the console. So you'll notice by default, so people can onboard pretty quick, we create an API key that expires automatically after 7 days. You could add other authorization methods. So you could add AWS security controls or Cognito user pools, or even your own OpenID Connect endpoint if you wanted to. So BYO OIDC essentially. You can enable logs in sort of the console. So I'm going to actually do that with a new role and make it all here. Save that. And then, data sources is essentially where you would add in some of these things like DynamoDB and Lambda and stuff like that. I'm not going to manually add that in right now because I'm going to provision it from a schema. So what does this look like if I provision it from a schema? Well, I come over to this schema page, and we build in one here in the console here if you're just getting started, so you can kind of just start from scratch and go from there. And all I had to do was uncomment it and add in a couple of things. If I wanted to, I could update this a little bit, so maybe my post also has content string and some sort of rating. I'll make this a float, maybe something like that. That I could add into my post if I wanted to go from there. But all I've done is basically exposed a schema into my GraphQL API. I could introspect on that if I wanted to. So I came over to this queries page, right? And you'll see if I click the docs, just like standard graphical operations, I could walk through and see the queries, my type post. It has all of that stuff like the content and rating. But I don't have any data sources, right? All I've done is added a schema to my endpoint. So instead of having to go to one of those data sources and manually do it, I click on this little Create Data Sources button. And it's got my logical type of post that's listed here. I'll call this post table Thursday demo. And what we do is we look at that and we auto-gen a whole bunch of information for you if you want it, right? So you can see a get operation, a list, nice input types for creation and updates. We'll automatically create subscriptions and mutations for you. If you wanted to, you could also add things for additional querying. So let's say that I wanted to query by that rating that I added. So I'll call this, my rating index. And you'll see that down here, it actually pre-populated some of that in my GraphQL schema automatically for me as well. I'm going to click on create. And what this is doing is it's going to create the DynamoDB table. That's probably the longest part of this, is just creating the table behind the scenes for us. Then it's going to look at the schema. It's going to figure out all of the different places that it's extended the schema, like the new queries and mutations and subscriptions. And it's going to automatically wire up all the resolvers for you. So immediately I can come over and I can look at the data sources. It added that table for me. Click on a little link. This will open my table. You can see here's my table with no items in it because I haven't done anything yet. But I'll come over here to the queries page and let's add something. So I'll call this mutation. I've got all of the nice, automatic creation capabilities in the console. So being able to do all of the like tab completion is what I'm doing here. So let me just type that again. Can't talk and type at the same time. So I'm going to do create post. I will do on this here an input type. And I'll do ID 1, title, Thursday demo. I'll give this content sync demo, a rating of 1.0. And my selection set that I'll come back to me is just with my ID. So I run this mutation. And if I go over here and refresh my table, you can see it actually added the data. It's my own data source. And I could run, queries and other things to list some things, right? So I can do to add in some data, right? And instead of going over there to the console, I could also query this information. If I do list posts, get the items, go to tidying content, and I'll call this mutation M, query Q. We've got these in the same pane. Can run through the queue, and I got back a couple of things, right? So this is kind of like a basic introductory walkthrough of the AppSync console and some stuff that you can do with it. Let's go through a couple of more of those advanced use cases that I had before. So I actually want to this up and then start this again. Oh, that's starting up. There we go. Cool. So I showed like the first screen when I was walking through this. I showed how you could start from a sample schema. Well, I've actually already got that running in another API already set up. So I've got this sample schema. I've got a couple of other modifications to this API too, but you can see here in my schema, I've got some stuff like the comments here, and this is connected to those events that I created, like the event creation and stuff like that. What I'm doing is I'm starting in the other screen my sample application, and just so you see there, like the way that that works. Let me make this a little bit bigger. This is the actual sample app that I've got downloaded. So it's standard React Apollo that you would do. So I've got, this app.js, and you can see I've got Apollo provider, and then we can pull in our AppSync client here. And all we have to do is create this AppSync client, pass in a little bit of configuration. That was that bundle that I downloaded, or I showed the download button before. And then I pass this to the Apollo provider, right? So this is what's going to give me the capability to do some queries, do some offline mutations, as well as do my real-time subscriptions. So for instance, you'll see that I'm subscribed to just the event comments. It's a standard GraphQL subscription. The mutations I'm going to do when they're offline are standard create event mutations. I just happen to be in my components. I'm going to use an optimistic UI on some of this. So showing really quick, what that looks like here in the console. I've got list events already written out here, so I'm going to run this get something thing, and you can see it came back with a test. Let me the where, just so you see there's no man behind the curtain. Test. I made this yesterday at Cafe Vita, and that's what I've got here on the screen, and I've got 10 comments already listed on here. But what I want to do is I want to show you, the first thing I'm going to do is show you a GraphQL subscription kicking off. Close this down really quick. and I will create online demo. I'm in Seattle, in the office right now. Save this. And so this created, my new event. And if I go back and refresh in my console, right, you can see I've got that online demo listed here. But it didn't pop up over here because, the whole thing was I only subscribed to comments on the event, right? And this is one of the powers of GraphQL. I can choose, at a very fine-grained level what data that I want to subscribe to in real time versus offline versus connected and stuff like that. But I can pop into here now, right? And because I subscribed to, real-time connections on the event comments, I can type some comments in here and it'll go over, GraphQL subscription channel, and it'll pop over into the other subscriber as well. So automatically, I didn't, from my client, I didn't need to do anything except import the AppSync client, and then I can use the standard Apollo HOCs and, subscribe to more and stuff like that to wire up GraphQL subscriptions. Nothing extra that I needed to do as a front-end developer. But I also talked about like the offline pieces, right? And if I go back to the events, and this is why I usually use Chrome for this demo, because it's kind of hard in other platforms to showcase offline stuff. But I can do some offline capabilities. So what I'm going to do is I'm going to come over to this network tab, and I'm going to click this offline. And I'm going to create a new event. And I'm going to call this offline test demo. Again, I'm in Seattle right now. And I'll call this description testing offline. And I save it, which is pretty cool because you can see here, like I've got optimistic UI, right? Like it immediately showed up here on my client. I can go into it if I wanted to display some of the enter and comment information. I've got this disabled right now. And if I go back over to my console and I run, listing everything, right? I've still only got those two events because I'm simulating my client being offline. But if I come back over here and I enable on, turn it offline, you can see it already fired off the GraphQL operation, and I can come back over here into my service and I can run this query for get something again. So this is kind of some of the onboarding stuff. I'm going to show just a couple more things really quick of some advanced scenarios that people usually like to see. So let me clear this and this one. So I mentioned, that use case of, connecting your information to your not only your GraphQL backend, but to an S3 bucket for like a photo sharing app and something else. Well, what I've done here is I've got, and it's in a different region, it's Virginia, that sample that I showed for automatically, wiring up with fine-grained authorization on a per user basis to your backend that also allows you to do photo sharing. Well, I've got that sample already running here, right? So it's on GitHub. You can rewatch the recording or contact us after, and we can send you the GitHub link again. But what that basically sets up is it sets up, this picture type. So you can see I've got, let me make this a little bigger, a picture. And because I want to do fine-grained authorization, I want to set an owner on it. The file is an S3 object. So what that S3 object looks like is just a bucket key in a region. You can also, if you want to, set the MIME type and some other things. But we give you an input, and we give some operations like getting a picture, listing pictures, query pictures by owner. And we enable on here fine-grained authorization by using Cognito user pools. You could also do this with OpenID Connect and other things as well. But the idea is to show the application running. All somebody has to do is first of all, they come in and they log in. This is a demonstration of like what Amplify gives you as well. So I'll show you in a second how we wrap that with our HOC. But I've got it set up so that I can not only log in, but I can log in with MFA. It's going to send me a text message. 1 second. Code is 597. So I've logged in, and you see it actually, once it logged in, right, it ran a query that filtered down to give me any images that were just for me, for Richard as being the owner, right? And so it ran that in the service. And just to show you really quick, since, just to show you that this is all still running in your account, here's actually the query that it ran against, since we're coordinating this with a DynamoDB table, and you can see it like filtered down, oh, Richard's the owner, so those are the records that we're going to return just to him. And these are the actual items that are in my own S3 bucket. So you can see that it's locked down to just me, the user, that only I can get to them. But I could, view some of these prior ones, or I can add a new one. Like I'm going to add, demo photo, use a file. I think I have a Carbon code snippet. Yes, I do. And I'm going to add this photo. So it did a GraphQL mutation. You saw it actually spun for a second while it was doing the write. If I go ahead and refresh my table, it's actually in there. So it went ahead and wrote the record through a GraphQL operation. And then I can, of course, do the reverse process, which is do a query and then download the photo and display it inside my console here. This is actually an example of using, some of our GraphQL API inside the Amplify client. So really nice, comprehensive way of using something like AppSync to have a lot of power and capabilities around building not just something that you can just do basic queries and mutations against, but you can tie this in with all sorts of different backends and create really comprehensive, offline, real-time, and even photo sharing apps and stuff like that. And to kind of show you the last piece of this, another feature that I briefly showed you a little bit of an architecture diagram before in the presentation of like combining NoSQL databases with like search capabilities is I've got a demo of that already running as well. So you can see I've got this DDB to ES. This is DynamoDB streaming to Elasticsearch. And in this example, what I've got is two different data sources. So I'm going to mix and match a DynamoDB data source along with an Elasticsearch domain. And I'm going to stream the data behind the scenes from this DynamoDB table over to this Elasticsearch domain, so that when you do like creating of new items or deletion of them, they automatically show up in your search results as well. So what this looks like is I on my schema here have, let's say I wanted to create a blog post site with like authors, titles, contents, and stuff like that. And I wanted to make this searchable, right? So what I'm going to do there is I created a couple mutations like putting and deleting some of these posts. And the queries on them will either correspond to list operations against your NoSQL database, which is DynamoDB, or the search operations will correspond to your Elasticsearch domain. So if I scroll down here to data types, you can see the single post or the all post, that's going to go a list against my DynamoDB resource. And then the search operations are going to go against Elasticsearch. Let's see what this looks like. So I've got one already queued up to use for Gabe in a second. So I'm not going to add that mutation yet. I'm just going to do the list operation against Dynamo. It's a little bit bigger. You can see I've got a record for Brian. He likes baseball. Gene's one of my friends. Nadia, Lee, he's got dinner plans, and a guy named Francisco. Basketball is awesome. So if I wanted to search this content, like let's say that I want to search for any content that's got the word football in it. So I'll put it in this search capability. I click search, and it gave me just that one record. But Gabe actually loves Delray Beach, right? So if I add a record for him, you'll notice a couple things. One, it added, but it actually did server-generated IDs. So we also support that feature. And when I showed you the onboarding one before, I manually typed out the ID, but you can have in your GraphQL resolvers an auto ID feature that will give you a well-distributed hash for your NoSQL tables. So we have a lot of nice things for making that easier for developers to not have to think about creating UUIDs and stuff like this. But it immediately I can run the list operation, and there's Gabe's record that he's got here. But if I want to, right, it's not just doing the list operations immediately. I can also search this content, and it's streamed over from the NoSQL table all the way to the search domain as well, so that I really have this Uber database system on the back end. So I can come, in these last two demos, I kind of demonstrated how you can take, you can start from simple GraphQL schemas and basic operations to add in real-time capabilities, offline capabilities, mix and match, standard database operations, which are atomic with, full text search capabilities, even if you want to do geo lookups and stuff like that, as well as combine it with rich content for things like S3 and so forth across all those videos. So this was a lot of information. I will turn off the event mode in a second and also pop back over to the session to take some questions. So I'm going to disable event mode, and Nader and others, I'm open for some questions or other stuff.
So I have a quick question before we get to the other questions. On the streaming from Dynamo to Elasticsearch, does the stream work on not only creation but also mutation and deletion of items? Do they automatically get updated in your Elasticsearch once streaming is enabled?
Let's see. So if you remember, so I shared out my screen again, and you'll notice I have this delete post here, right? So I'll come back over to the queries, and I'll run a list operations, and I'll take Gabe's ID here, and I'll run this delete operation. And I run delete, and I run list. So you see Gabe's no more in this list, and now I'm going to do this search again, and it didn't come back. So looks like it.
Cool. So are you logged into the Reactiflux Discord channel? If not, I can.
Not. Yeah,
okay.
I'm not.
Let's see here. I'm going to go ahead and start moving over some of those questions.
Sure, or if you just want to ask them verbally, Nader, I can answer some.
Okay, cool. Let me pull up that channel for some reason. I'm not seeing it here. Oh, here we go. Okay, I'm going to scroll kind of towards the top and try to find the first one. So there's the very first question is kind of more around some existing functionality. Is there, or can we get a reference CloudFormation template for creating a custom domain for an AppSync API? They were unable to replicate the setup described in the tutorial that's in our documentation.
A custom domain.
If they mean the link that they referenced.
So that's a okay. Yeah, we can look into a CloudFormation. That's not in the reference docs. That's one of our reference log posts. But we can look into a CloudFormation template for that. Yeah. Have whoever asked you that, Nader, follow up like via Twitter or something.
Okay, cool. That's a good idea. That sounds great.
Okay, I guess it was Cody that asked.
Okay, so I'll jump to the next question. What are your recommended approaches for geospatial queries on data in your DynamoDB? And I'm guessing that's going to go around Elasticsearch.
Yeah, so DynamoDB is not great for geospatial queries right now. You can do it, but if you are going to start getting hundreds or thousands of records, which most likely for people's applications where they are doing some geo lookups, especially for like geofencing, we get a lot, and other things like yes, you can store basic latitude and longitude and stuff like that. But when it comes to geo lookups, most people are trying to do like radius lookups, or they're trying to do like hexagons and different star patterns and stuff like that for fencing. And that's really where something like the indexing of and lookup tables of Elasticsearch are really advantageous when it comes to scale and speed. So what you that's why we recommend stream either directly using a post into Elasticsearch domain and doing your queries for geo lookups against that. Or the best practice is really to store the data in DynamoDB for like regular list operations, and then stream that data like I did in that demo over to Elasticsearch. Because Elasticsearch, really at scale, you shouldn't use it as your primary database. If it's just something like you're hacking around on and stuff, yeah, maybe. But if you're building anything to where you want full scalability and redundancies, your primary source of truth should be something like DynamoDB.
All right, the next question. Are there any plans to develop an AppSync client for outside a web mobile client? They're using AppSync as a backplane service as well, and have had to develop code to deal with the signature version 4 signing when invoking the API from a Lambda function.
Yes, actually, a standalone one that you would want to do like a mutation from a Lambda function for SigV4. Yes, we are looking into that. We just haven't gotten to it yet. A lot of people right now are using like Loca and a few other things for more lightweight Lambda function to do GraphQL operations. Yeah, I don't have a timeline on that, but I can ping a couple of people and see when we can get to it. We're also looking at enabling some mixed mode off pieces on that in the future too.
Next question is, are there any plans to change the behavior where the mutation that triggers a subscription determines the actual payload? They say that it seems like that coupling would lead to problems on larger teams and APIs, especially as the API evolves.
Yeah, we're looking at ways to tweak that a little bit in the future and do a little bit more around potentially server-side selection set filtering. I will give a little bit of a background on that. For projects that you're just kind of spinning up a node server and running a couple of things here and there, with subscriptions, it's very easily to do the kind of all of the selection set just in your single node process or something like that on a service. AppSync is really a platform that's designed to scale to millions of users and stuff like this across different regions for all sorts of different apps, right? And the way that if you look at cloud services, usually the way that we try to do algorithms for scalability reasons is linear or sublinear algorithms. And the way that the GraphQL spec on some of those things is written is actually quite different than the way that Facebook themselves have implemented GraphQL. And the subscription spec is actually an n-squared algorithm, which is very hard to scale and do everything with a server-side query, or even if you occasionally hear people talk about like live queries and stuff like this. So if you were building like an individual product and you wanted to try to just throw raw compute horsepower at some of those problems, that's probably doable. On a large scale platform like ours, where we're trying to do things that can meet the majority of customers' needs in a scalable way that's also very cost efficient for you, that's why we do have this event-based model. Now, we can still do the event-based model with doing some more server hydration on that. But when we do these things, we're going to be very careful to roll out the changes over time because we want to make sure to do it in the right way that we're not going to bring down like your or other people's applications.
All right, next question. What other authorization types are being worked on, if any? They'd like to use DynamoDB to store data and AppSync for login and register mutations that return a JWT token as a simple authentication system. A way to choose a custom resolver like a Lambda function to do custom functions like encoding or decoding a JWT session data as an authorized method would be amazing. AWS Cognito is great but expensive, and IAM is good, but I'm not really sure what approach to take with it. I'll go ahead and paste this question in as well because it's kind of long.
Yeah, I got it. Makes sense. Yeah, so a couple of things. One thing on the Cognito user pools, if you're just doing basic, from a cost perspective, if you're just doing basic JWT, and you're not trying to do some SAML stuff, it's actually pretty competitive from a cost perspective. In fact, like it's free up to 50,000 users, which, frankly, if your app gets big enough for 50,000 users, that's pretty good success. But that being said, like what we really, we will do some things in the future around some more Lambda-based authorizers and so forth. but we're going to do it in a way that you can essentially chain some resolvers together from a GraphQL field level perspective. So what we don't want to do is pull over REST-based principles and just blindly apply them to GraphQL operations so that you get like something that's really not natural. The other thing as well, which is interesting about this question for doing some encoding of session data, reason why we haven't tackled that just yet is a lot of the decisions we make around AppSync is we're trying to make it as low cost as possible so that a lot of the common operations that you as a developer would do, you don't have to pay for, right? Like for instance, yes, you can use Lambda functions in resolvers right now, but you have to pay for it. And, it's also then you're taking like latency in your own hands for like issuing responses and stuff like that, which is why we have, this language, for templating resolvers, VTL, which is Turing complete, but it's also deterministic on the execution time, right? So we want to do some things there to improve the language in the future, maybe make it more JavaScript-like, but some of the decisions and the existing features that we have, both around auth and scalability and other things, are really so that you have a consistent way of interacting with the platform, but it's also not going to like break the bank for you.
All right. So the next question is: Are there plans to provide a directive for fine-grained authorization, but with IAM authentication?
Yes, we are actually doing, we're doing a bit of work over the next few months around some enhancements to authorization. And that is actually one of the things that we're looking at. Some of that's out of our control because it's some existing, what's known as STS is another AWS service, some existing information that's not encoded in all of the tokens, and there's reasons around it from client spoofability and so forth. But I can't guarantee that we'll have that, but we are heavily looking into that right now.
Okay. It looks like I kind of skipped over 2 questions by accident. The first one is, Richard, you mentioned upcoming data sources early on. Are you at liberty to disclose?
I can't disclose them, but you'll see some stuff potentially in a month and a half.
The next question is, how can I put the SDL code under source control so I don't have to solely use the AWS AppSync console?
So SDL is text, and you can check it in. What I can say on that, though, what we are doing right now is if you haven't checked out the AWS mobile CLI, we did a version of AppSync integration 2 months ago that will export and synchronize the schema down to your local project. So you could change the schema locally in your React project or just a regular, Git initialized folder, and you can push it, and it will synchronize not only the schema, but also all the resolvers, and it'll do the flip too. So you could actually change some of the schema in the service and download it. That was really just an initial piece of work, though, that we could get some of those basic workflows. We're working on a V2 of this that's targeted at the mid to end July timeframe that will enhance this functionality even more so that you can do, regular CI flows.
All right, so I think, let's see here. How do you do sync ES with DynamoDB?
Synchronize Elasticsearch and DynamoDB. So synchronizing them is, it uses basically a DynamoDB streams and a Lambda function. And we have a sample application in our, so we have a sample inside of our documentation on how you do it with fully functioning code. We will be doing more in both the console as well as our automation tools to allow you to do it without even having to code anything in the coming months, though.
And the last question is, so would AppSync be a good fit for augmented reality apps in general? An example would be a Yelp-style AR app that a user would walk around to see info over buildings.
Yeah, I think you could do quite a bit around real-time subscriptions for some stuff. We have some customers that are already investigating those things for like, moving items from one screen to another using GraphQL subscriptions. If you're building something like that, I'd love to hear more about it. So reach out to myself or Natter on Twitter.
Yeah, actually ping me. I'm actually playing around with some stuff around that as well, around AR. So I think that's a pretty cool use case for subscriptions. So I think that wraps it up. Gabe, thank you for having us. I'm gonna go ahead and post again the awesome AppSync repo here for anyone that wants to either look at that or contribute to that. We are trying to combine most of the resources in a few places. So one of those is the AppSync documentation, and then the other is going to be here for more external facing things like Medium blog posts and YouTube videos and things like that. Richard?
Yeah, thanks so much, Gabe, for having us. We're really, really, really thankful to being invited and for speaking for everybody in the Reactiflux community. We hope to talk to more of you again anytime.
Cool. Well, ping us on Twitter if you ever have any questions.
Thanks.
Later, everyone.
Awesome.